What is up, Internet? Welcome to another IT Pro show to keep you in the know, brought to you by your friends at Scale Computing and at Spiceworks. Today, we're going to be talking about fast track container applications in diverse edge environments. And I know that sounds like that movie, Don't Worry, Darling. We're not talking about Tupperware Party here. We're talking about modern computing environments and how to make those the most efficient and save you the most money. So, I am not going to do this by myself. We brought in a panel of experts to help you really zone in on your expertise of this topic. So I will bring them in right now. So, batting first, he is the CTO and co founder of Avassa. Please welcome Carl Moberg. Carl, how are you?
I am good. Thank you for nailing my Swedish last name. Deeply
Yes,
appreciate it.
I was
Thank you.
really hopeful. And thank you for that awesome 3D map of the world behind you. Talk about having
Like it.
everything under control.
Yeah,
Nothing says I have it all under control with a map of a world right behind you.
exactly. And I'm up here for everybody. I'm in Sweden. Yeah, there we go.
Yeah, that looks awesome. So that's a you are here map. Awesome. So thanks for joining us, Carl. So batting second, he's the store IoT lead at Lowe's Companies. Please welcome Tom Gardner. Tom, how are you?
I am good. And
Good,
thank you for
Tom.
getting my German Irish name correct.
Well, I have this whole thing that the words I get it like almost right almost every time. It's always almost, but yeah, Tom, thanks for joining us today. And batting cleanup, he is the product manager from Scale Computing. Please welcome Mitch Etchison. Mitch, how are you?
Good. Thanks for having me. I don't have a
Good,
cool
man.
map or name or anything to add to the conversation.
That's okay. I like it more, a little more ominous, right? You're not too sure what's behind you. That's what we need, and because it's IT, right? We never know what we're gonna get.
Yep.
Awesome, guys. Well, thank you for joining us. This is a topic that I think we're going to generate a lot of conversation in there. The chat is already active as always. They do deliver. They know the assignment, so keep those chat going. And we do have that Q&A widget, so feel free to ask a question. So about 30 minutes in, we're going to go to a live Q&A, ask your questions, and we will be giving out. That's right. Prizes. We always have a great prize they're going to be good. So if you want to be eligible for that prize, go ahead and start asking those Q&As early. So, guys, let's get things warmed up a little bit. We can't jump right in, right? It's like one of those ice cold plunge pools. We got to somehow start to get our bodies ready for this. So, in honor of today's topic, I will start with you, Carl. When was the last time you felt like you were living on the edge?
I think the easy way for me to answer that is to say, look, I work for a company with a cloud platform and a company where we deploy into production in an automated fashion. And I'm not going to be foregoing the conversation today, but that makes you feel like you're living on the edge a couple of times a week. I will tell you, rolling upgrades does that for you, and I'm sure both of my speaker buddies here can attest to doing that. So I'd say last week we had some interesting upgrades that made us all sit towards the front of the chair, let's just say, when that was happening. So I'm fortunate to have a day-to-day job that keeps me on the edge in so many ways, including on a personal level here. So that'd be my my comment.
That reminds me of that meme, when you're serious when you're gaming and you lean forward and the elbows hit the knees and you still have them. I know I've been through many of those upgrades. Like, okay, now things are about to get serious. Elbows
Yes,
are on knees. Let's do this.
yeah, exactly.
Tom, we'll go up to you next. When was the last time you felt like you were living on the edge?
Yeah, I'd have to agree with Carl where, daily you go through some sort of slipping almost over the edge. But when the question, when I heard the question, it was so there was a housing crisis in 2008, right?
Yeah.
And it was the year that I released my home automation platform. So, of course, nobody was spending any money on their houses. So it was pretty much bad timing. So
Oh, yeah. It's all about timing, man.
it was all about timing. Yeah. So
in
I fell off
2008
the
was.
edge. They ended up falling off.
Well, as long as you have that grappling hook and you hung on and you're still here, right? So we don't go
Yeah.
all the way over the edge.
So.
All right, Mitch, you're up. When was the last time you felt like you were living on the edge?
Yeah, might be a little bit less of a technical answer, but a few months ago, I was actually with Carl in Las Vegas for our annual conference, and Carl and I ended up in the karaoke room doing a duet. So that's probably the last time that I really lived on the edge.
And I'm
What was the
assuming you're.
song? What was the
You
song?
can,
It
man.
was
Yeah.
"There's a Light That Will Never Go Out" by the Smiths.
Huh?
Oh, yeah, that's not easy either. That's not an easy one.
Yeah.
I thought you were really gonna nail it like on the nose and say you're singing "Living on the Edge" because every time that comes up, you hear Steven Tyler's voice scream through your ears that we're living on the edge.
Well, that might have to be my new karaoke go-to. So now I always have a really great answer for this type of question, just built
Right.
in.
That's the hack. You have to have 5 songs
Yeah.
in your back pocket. You have to, because when you go up there that first time, you gotta let them know, and then you experiment a little bit halfway through. So, yeah, I get it. I did a living on the edge. I fully committed to a fully electric vehicle and finding all about of just like range anxiety and when to charge and how long my battery's going to last. You really didn't realize that how much of a thing that was. And then like, you know what? I'll probably just rent a car on a road trip. I don't know if that's how much we want to live on the edge on that. So we'll wait a couple years, like you're talking about, Tom. Maybe when things are timing, it's all about timing. We need that infrastructure in place. So, all right, guys, good stuff. So let's get started here. So, Tom, I'm going to start with you here. What has been your experience expanding the IoT capabilities in edge environments?
Yeah, I started out with building management. So I have about 25 years of IoT, and it wasn't always on the edge, but more and more over time, we started to, back then they were called gateways. So not edge computing devices, but essentially what they were. So we would implement more and more logic there. For example, thermostats, right? If the thermostat in, well, let's just pick California. I'm in Newport, right? And the weather in Newport, believe it or not, it said low of 59 and a high of 61 all day. Crazy weather. That's like
What a
insane.
range
I don't even
there.
know why they put it there, right? How can you
Yeah.
tell? But so in a house or an apartment, we were managing apartments. If the thermostat didn't move, there was no reason to keep sending the temperature up to the cloud, right?
Right.
So we thought we would do some edge computing and put some logic into the edge. And that was kind of the first thing. And then we started putting more and more and more intelligence from the cloud into the edge device, really to save traffic and to be a little bit more smarter. Now I'm in retail, and it's somewhat of a struggle to convince people at Lowe's to get their head away from, oh yeah, we'll just do that in the cloud. Oh yeah, we'll send that up to the cloud, where they have essentially in the store their own data center in the store. They have a mainframe in all the stores, which they're moving against. So there's a lot of compute power there that we can do a lot of stuff in the store. So, but still, it's a convincing task that you have to convince people to think differently. You know,
Yeah, that's a
so
good point. I mean, think of like when you say, the whole just put it in the cloud, it could very easily and very quickly turn into a junk drawer or that closet where you just keep sticking everything. Now, what is in there and how is it organized and how is it usable? How is this going to be efficient and all? Because you just kept putting it there because it was easy, right? You have the Jeff Goldblum. Just because you could doesn't mean you necessarily should, or if you are going to do it, think about exactly how you're going to be doing it, to make your technology life a little bit easier. So Carl and Mitch, and this will be both for you on that topic. So, what benefits can containerized apps and virtual machines provide to edge environments like these retail store locations that Tom was talking about?
Sure. So maybe let me start. I think we have a very natural distribution between Mitch here, and I'll use Tom as the jump off point. And I think the general perception that we're all kind of working with on a day-to-day basis, whether it's Tom inside of Lowe's or me inside of Avassa or Mitch working with scale users, is that there's a perception that it's hard, right? That it's a complex and hard, nut to crack here. But of course, we happen to not think that it isn't, and we're happy to try and prove that, because the benefits obviously is getting pretty close to to include what Tom mentioned. There's a whole slew of economical benefits of actually performing activities on data close to where it's actually collected. So in his case, there are benefits including things like outage resiliency. Of course, Tom's intelligent IoT devices would probably have survived outages if it had a little more intelligence in it, and it can also keep data local for you. So there's a number of top level benefits of building or putting applications closer to the sources of data, be that humans or containers, or sorry, humans or machines. And my expertise, happens to be containers. And what I think is a great benefit of that is that it's the up and coming kind of universal application packaging format, which means that what used to be a very exotic environment, I'm sure Tom and the guys had their own tool chains, their own compilers and linkers and everything to change the running code on these IoT devices. While today, of course, the effort of moving a containerized application, and I'll leave the VMs to Mitch, to the edge, is a breeze. The barrier is really low. So extending their current capabilities today is a much simpler.
Yeah, I mean, I absolutely agree, and that's what we see at Scale too. Is containers are universally agreed now that it's the next generation of application deployment for all of the reasons that Carl mentioned. They're more portable, they're lightweight. But when you combine a tool like Avassa to deploy containers with a platform like the Scale Computing platform, deploying containers inside VMs allows you to maximize the convenience and ease of use of managing containers, because our platform provides things like snapshots and replications, using built-in data resiliency and kind of those benefits around managing the hosts themselves, rather than if you were to deploy containers kind of out to thousands of locations in the field on bare metal devices, because then managing and maintaining those becomes much harder, and you start to minimize those benefits that you get from the streamlined application development and deployment with tools like Avassa. So we see that kind of combination as being really powerful for a lot of our combined customers in the field, where they can use a super lightweight VM OS as a shell essentially to deploy containers remotely in, and then get all those benefits of virtualization when it comes to the actual host level management.
I love the idea of, like you said, it's the mega powers for my pro wrestling fans out there, Hogan and Savage coming together, scaling Avassa with that handshake of just making that mega powers and making everything way more efficient. I love it.
I was just going to follow on with I saw some of the things that were mentioned in our document about running side by side, right? And so our environment is we still have this AS400 IBM mainframe thing that runs, the heart of e-commerce, which runs, so you don't want to rip it out because it's worth too much money, right? But
Right,
you also
exactly.
want to transition over and pull out the services and run them side by side, and then, antiquate and get rid of the ones as you move into the new environment. So that part of the process, I'm interested in hearing about, how that happens.
So you feel like is that like one of the biggest challenges that you're facing with edge computing? Is it you think it is the we spent a lot of money on this, so let's keep going in this direction? Do you think it's more of less of a financial change in mindset and more of just like a philosophy change in mindset? Like, what do you think some of the big challenges are with edge computing outside the data center?
Well, I think I'm lucky because I'm running a team that I've put together the architecture, which is it's container based, it's Rancher orchestration, um, but we have to ultimately we have a platform that interfaces with all the telemetry devices. Just call them those. Some are cameras, some are registers themselves, some are beacons, trackers, RFID, things like that, devices in and around. And to communicate with those devices, we have an infrastructure which is modernized, right? But the registers themselves and how a putting an item in a cart, that process of putting it into a cart goes back into an inventory management system that's managed by all those antiquated products. So you're running side by side with those products and trying to get them to move at any kind of reasonable pace is very difficult. And I know they're in the process of moving those services off those platforms and into a new set of services, which would be easier for us. So for us, we're sort of modernized, right? But we deal a lot with the existing infrastructure, and the turnover time is incredibly slow too, painful.
Well, I mean, hats off to you. I mean, you're with a company that's not exactly that just spun up yesterday, right? So, we always talk
Yeah.
about trying to keep up with your tech. Now we're beyond the whole let's change the tire while the car is moving. Now we're like, let's upgrade and rebuild portions of the car while we are driving and while we're on the interstate and while we're in traffic. So, I mean, it's not exactly easy. So props to you for trying to at least sometimes we do it, there's a little bit of a risk that, you've got to modernize, but you can't modernize everything at the same time. And that's why having partners like Scale and Avassa that like really can look at your situation and like, okay, let's do this. I always attest it to, when I worked on a moving truck and then you see the people that said, well, the last time we just rented a U-Haul and we tried to do this ourselves and it took us 5 days and it took forever. And it's just like, no, you hire the people that have been doing it. They do it every day, multiple times a day, because they're gonna be seeing scenarios that you've not seen before, right? So having these key partnerships are really gonna just make your life a lot easier. So on that note, Carl, Mitch, so how are Avassa and Scales Computing partnering to help businesses leverage some of these solutions?
Yeah, that's a good question. And, I see the two solutions working together really well, particularly at initial application deployment and orchestration. So it kind of starts with the scale computing platform. We have a technology called zero touch provisioning that allows IT infrastructure admins to remotely provision a scale cluster so that when the actual hardware reaches the field, the nodes, once they're plugged in, connected to networking and powered on, they automatically reach out to our cloud based management tool called Fleet Manager and initialize from start to bottom the full hypercore cluster. And then from there, through our Ansible collection and support of tools like Cloud Init, those same admins can then automatically start provisioning virtual machines to then hand over to Avassa for container deployment. And so that can be automated quite literally from hardware arriving on site to running an Ansible playbook using Cloud Init to automatically deploy Avassa's Edge Enforcer agent. And then from there, Avassa can take over and allows those application development teams to start deploying and manage and orchestrating the application deployment remotely. And so, Carl, I'll probably throw it to you to provide a little bit more context then from after, the scale automation has taken place. What do you see happening on the Avassa side?
Yeah, that's what we really love about working together with you guys is that we get a, let's say, edge first hypervisor management solution that, let's say, just removes the onus from us to provide a solution that would require hardware bring up, and of course all kinds of very, let's call them, interesting challenges when you assume the responsibility of keeping an operating system layer up to date, let's just say. So with a VM based infrastructure, in the mix, we get a lot of benefit from that. And just like you said, using the tooling that you have on an installed infrastructure, it is trivial to then start up VMs with Avassa workloads in them, or with our agent forcer in them, that then will, based on what you guys put in cloud in it, will call home to its control tower. And we can immediately, literally minutes after hardware boot, show how to connect something like a GitHub or GitLab based CI/CD, or for that matter, AWS CI/CD pipeline, and start deploying well, in our case, then containerized applications, and then use whatever automation Mitch mentioned to keep the VM workload up to date. So the combined solution we think is awesome. We can really shape it around the maturity of the user. If they're fully, containerized, but they like the kind of hands-off management of VMs, then they can lean on that. If they're a mixed bag, which many of, literally people that have edge workloads today, including Tom, has, then of course a solution needs to be able to cater to two speeds, right? The VM speed of things and tooling, and the container speed of things. And of course, Tom is not alone in that. It's very traditionally true for everyone who has hundreds of locations in a retail that have AS400 or worse, of course, in each location. And we think, again, we can delight the people that come bearing applications, independent of the age of the applications, with a kind of a mixed solution like that. So we're happy about the combined value here.
That's awesome.
Yeah, the AS400, it runs AIX, right? And I worked on AIX at IBM a long time ago. So it's running software I wrote. I wrote the login program. So it's the first thing that you see.
Oh, that's awesome.
Wow. So does that mean that you are the support engineer for the entire setup?
Yeah. No, I can hack into anyone I want. Yeah. Yeah.
Oh, that's incredible. Now that is a solid foundation.
Yeah. Well, I have a short story about that. My kids went
go for
to.
It, yeah.
It's I think it's called NOAA. It's the Atmospheric Research Center in Boulder. So you go up there, and they have in the basement Big Blue, which at one time was the most powerful computer in the United States. And so we were looking at it, and the room's full, and they had one terminal out front. And right on the terminal is the application I wrote right there. And I told them, I wrote that right there.
That's incredible.
Were they impressed? Were they honestly impressed?
They didn't know what I was talking about. No, but it sounded cool. It was great to me. It's awesome. But on the so you mentioned this whole VM thing, right? Managing VMs. So our current situation at Lowe's is, we have these containers, right, that are self-contained. They're running some sort of flavor of Ubuntu, and then they put their computer vision algorithm in it, or we put our services in it, or whatever. But one of the issues that we have is we need a real-time computer vision model running that's tied directly to the GPU that's part of the hardware. And so that's been a difficult thing for our team, our CI/CD team, our DevOps team, to do within the structure that we have within Rancher, because they for some reason can't give us enough memory, CPU time, things like that, and then give us direct access independently and being tied to a GPU. That seems to be an issue. Yeah. We have
Oh yeah, I
examples.
mean,
Yeah.
that's absolutely a trend, a major trend that we're seeing in the field is the need to harness GPUs for the computer vision type applications, particularly in retail. And so, actually, we were fortunate because our smallest platform that we ship on today is based on the Intel NUC. And when talking with
Mm.
customers, we just kind of realized that, well, the Intel NUCs, the NUC 10s and NUC 11s that we've been supporting customers on for a few years now, just already have GPUs available. And so from there, it's been pretty trivial to architect hypercore to be able to just pass through a GPU to a virtual machine running on the cluster. And we have done internal testing with a bunch of computer vision type platforms, and even things like live video surveillance monitoring that require GPUs. And definitely see that use case is going to do nothing but expand over the next few years as the kind of edge market matures and we uncover more and more use cases where the application needs to be out of the data center at that edge of the network.
Well, for us,
Yeah,
there's three scenarios, right? There's out of stock detection, right? So out of stock detection, if you're monitoring somebody as they're checking out, you need sub-second response time. So that particular computer vision algorithm needs to be tied to that GPU and use it, where people counting, dwell time detection, out of stock detection, any of those kind of things that could take a few seconds or even minutes to perform, who cares, right? They can have a virtual shared access to that piece of hardware. But the out of stock detection needs to own it and be tied to it. And so getting that containerized, application, which has the computer vision algorithm in it, directly tied to the hardware on that machine is something I think our team is struggling with.
yeah, I
Yep.
can add some observations to that, and just also kind of what Mitch is saying. I mean, we see that across the board. And it's interesting because it's almost like a little conflict between the flexibility and the kind of benefits of virtualization and containerization in terms of general abstractions, but at the same time, the need for almost or fully real-time access to particular hardware configurations. I think it's a broad and interesting topic, and I'll add one more. We have a number of users requiring shared access. I think you almost mentioned that, Tom. So
Shared,
think
yep.
of
Mm-hmm.
multi-tenancy, and slicing on the GPU for
Time
cost
slicing,
reasons,
yeah.
right? Because
Slicing,
time
yeah.
slicing GPU. And that's actually a very interesting, development that's going on right now. Is how do you actually time slice a GPU, and how do you provide a stable abstraction and provide access to VMs, or for that matter, containerized applications running inside of VMs. To that, without losing, like you said, the speed or the performance of the thing. And for us, we concern ourselves a lot with, of course, scheduling and placement of applications. So, for example, having application developers say that this application can only run usefully if it actually has real-time access to a GPU. We also need to figure that out from the platform so we can schedule, for example, in multi-host clusters where there may be GPUs only in one of the hosts. So we can put the applications on the appropriate hosts without exposing too much details, of course, to the end users. So it's actually a super interesting field, and I think we're getting there. Maybe not in a standardized fashion, but most of us vendors now have a means of doing it using, in our case, container mounts. So we're getting there. We're getting there, but it's a pretty recent development.
Don't we sometimes feel like therapists a little bit? It's just like we know consistent communications that is actually useful between people is how you keep relationships together. And it sounds like it's the same thing that we're talking about for these apps, right? We need them to communicate in real time and actually have useful data to actually bear any benefits. So we
That's
are
exactly
seeing
right.
that. So this is good stuff, guys. So we're about 30 minutes through. So I'm going to give the audience a little bit more time. Don't forget to ask your questions in that Q&A widget for a chance to win that Scepter 24-inch 1080 LED monitor. So one lucky question asker will get a chance to win that prize. So don't forget to we got a great panel of experts here, a citadel, if you will, of edge computing. So let's get those questions in. So Mitch, I'm going to jump to you real quick. Can you describe like some of the things Scale Computing is built to make edge computing easier?
Yep, absolutely. So we've already touched on throughout this talk the need to run a mixture of legacy and next generation applications, and I would say that's really where the scale computing is one aspect where the scale computing platform excels. We literally have customers that need to support 30-year-old applications alongside containers at the edge, and so we're providing a platform that allows those customers to modernize the infrastructure platform while also running existing applications that cannot be re-architected for the cloud or re-architected for containers quite yet, and gives them time and a little bit of breathing room to slowly tackle those projects as time goes on. But outside of that, more in general, I would say our two biggest differentiators and benefits for edge computing customers is one, ease of use, and two, reliability. So when we originally launched HyperCore, we really put a heavy emphasis on making it as easy to use as possible because particularly at the edge, IT infrastructure teams don't have time when managing hundreds or thousands of sites to learn a really complex virtualization solution. They essentially just need an infrastructure that they can set it and forget it, and they know that their applications are just going to run with minimal like actual babysitting of the infrastructure at remote sites. And so that ease of use is a huge differentiator for us as well as reliability. So in addition to our virtualization stack, we have a proprietary redundant storage architecture called Scribe, and that provides automated self-healing and combined with an AI ops engine we have built into the product called AIM. And so the two of those work together to diagnose issues with the hardware in real time and provide true fault tolerance and high availability at the edge site. So if you are running super critical applications at the edge, if a node or a drive fails on a HyperCore cluster, the product is intelligent enough to automatically move that application over to a healthy node in real time. And so that allows us, say in conjunction with tools like Avassa, provide true redundancy at that infrastructure layer, which then can also free up the application and IT teams to not necessarily have to implement a tool like Kubernetes, because they get the application orchestration and deployment from Avassa, and then they get the real-time uptime assurance from Scribe and Scale's native redundancy.
That's awesome, Mitch. Thank you. So on Carl, to add on to that, how is Avassa making edge computing as seamless to use and monitor as the cloud?
Well, see, most of our users, of course, I'll say most users in general are kind of, if not brought up, they are very used to the ergonomy and the kind of feel of the cloud in terms of managing applications. So what we really wanted to do is that we focused on these people. And there's a fine kind of line between the IT and platform team that reaps many of the benefits that Mitch is talking about, and people that care almost exclusively about their containerized applications. And you can usually identify them by hearing them saying things like, I just want to run my containers. That's all. I just want to run my containers in a robust fashion. I don't want too many details leaking up from the infrastructure. So we really focused on that and built an application or a platform that allows that kind of crowd, that kind of user, to leverage the tools they usually already have, some sort of CI/CD or release orchestration tool and some application layer management and observability, and allow them, again, to extend their capabilities. So instead of spinning out the separate and isolated edge team as opposed to the cloud application team, or even worse, have them swivel chair between the two, they can actually use a coherent set of tools that they already have usually and hopefully love to deploy applications to the edge infrastructure in a good way. So by focusing again on the applications and kind of almost defocusing on the infrastructure, because that's more or less a solved problem through Mitch and his software, then we can really complete the stack. So we can connect all the way from the hardware through the hypervisor operating system up into the application layer pipelines here.
I love it. You said it, chair on a swivel. We are the heads on the swivel by sitting on the chairs with a swivel. That is what life is in technology. So it's good to hear. So we got a couple of questions coming in, but let's keep those questions going. Just so I can't see how people wouldn't need a monitor. I have 1, 2, 3, 4, 5. If I count my phone screen, I actually have 6 monitors throughout the day that I need to. So I can see people saying, no, I'm good on monitors. So let's keep those questions coming in. But Tom, while we're talking about this, how do what Mitch and Carl talk about? How do you see these technologies helping IT professionals and people manage their edge environments?
Yeah, it was mentioned the idea of migration and moving applications in side by side. I think that's a really good idea to just sort of dip your toes in, pick a couple strategic applications that you can pull out and have them run side by side with the old applications, so you don't get in the way of our e-commerce, right? That's a pretty hard thing to touch, but you can pull out inventory management and pricing and some other kind of things outside of it and run those. So start there. And then if things get ugly, they get ugly. They can get ugly pretty fast. So and you can adjust, and it won't be it won't affect the whole operation. So
right. Yeah. And we know it's going to always get a little bit ugly because again, this is we're dealing in real time, right? And that's what we're trying to account for mistakes in real time. And sometimes there's going to be hiccups, and that's okay. And that's we try to make our environments as solid as possible with a lot of these techniques that like Mitch and Carl and you're talking about in real time, right? So final question before we get to the Q&A, and this is for all of us, and we can each take a swing at this. What would be your advice for technology professionals who are containerizing their edge environment? So I want to take a swing at that.
I would just say start at small. Start at small, do some proof of concepts, so everybody gets to learn it, right? If they're not familiar with it, just do a couple of proof of concepts, get up to speed, realize the value, and then move up from there.
Right. I mean, how many of, and like you were talking about, the lab environment is so big and it's so easy, partners, that we have that will just give you something to just take some, put your toe in the water, take a swing, see it for yourself on how when you're actually, I can, that way you can empathize while you're looking at the technology, go, okay, this is where I can use that. Sometimes you have to see it to actually be able to say, okay, now that's when you get the light bulb will go off.
And I'll add to that one of the more exciting parts of the conversation we're having with first-time users is not so much when they deploy their first containerized application across like a trial environment that we set up for them, 100 locations or so. It's that they, at that point, will inevitably start thinking about, how do I monitor this? What does it even mean to be a healthy application if it's running in 100 replicas, right? Nowadays people call it how do I do observability? If one of these applications are going south as fast as Tom just described, how can I get insight into what's actually happening in one of those locations? So let's do what the rest of the industry does, I guess, and call it just day two. Thinking about day two operations, not just getting your first container up and running, but thinking about what it would take to now upgrade parts or the entirety of that containerized application. Maybe there's 3 container images. What does it take to make sure that enough of them are healthy that you can call it like green in your KPIs? And if something goes south, how do you take a look at that behavior? So bringing day 2 into the mix, which again, to, I guess, Tom's point, it's inevitable. If you start in on it and if you do small POCs, you're going to have to think about, what does this mean to my operations team? What does this mean to my break fixing and all those kinds of things? So keeping day 2 and beyond in mind, I think, is key too.
whether it's Scale or another solution on the market, there are options out there for very easily implementing a redundant set of infrastructure at thousands of sites. And to Carl's point, having high observability into the infrastructure layer itself. And so, it no longer is incredibly hard just to manage servers or whatever compute platform you're using remotely. And so that shouldn't be a fear that keeps you back from wanting to either modernize applications and make them more efficient by running out at the edge, or deploy greenfield applications for new use cases that you or your engineering or data engineering team are discovering in real time.
Exactly. And sometimes taking everything we're talking about now, and then maybe we have to try to like sell it to management. We do have to remember, beyond the technology of it is the relationship between the partners. Like you see, like with Scale and Avassa, when you take these leaps, leverage the partnerships that you have. When you buy, again, you're going to see stuff because you do this stuff every single day, right? You're going to see different types of environments, and you can leverage this knowledge base that you have with your partnerships. So on top of the technology, I think the relationships, the partnerships that we build, like we see it in the Spiceworks community, these relationships really do help make your jobs easier. The vendors, like that's a partnership that you'll be able to see. Oh, don't worry, we have another customer that did this, instead of just having the old days of like it's 1 a.m. and you're pecking away and you're trying to desperately figure something out, recreating the wheel. I think these relationships is what you really use to sell a lot of these technologies to yourself, in a sense of willing to take that leap and say, okay, it's time to modernize my environment. All right, so we got some questions. Are you guys ready for the Q&A? This is the portion of the show where I usually butcher people's screen names. Not everyone makes it as easy as dim for us. That sometimes we just have to work through it, but we kind of get the idea. So again, keep the questions, you can keep them firing, and we still got a few minutes left here. So I want to present these questions to the Citadel. So the first one up is Nihao 24. What is your opinion on using serverless versus edge?
That's a good one. I can start because I do get questions in the same part of the Citadel now and then. Now, I guess the number one thing is to talk about the fact that serverless is a little bit of a moving target and a pretty vague term. Of course, so is edge. But I guess the way I'm going to interpret that question is in two ways. I'm going to be speedy and do it in two ways. So one, I guess, is to say, how do we compare solving usually data streaming challenges using serverless components in a centralized fashion versus doing it at the edge? And of course, that one is pretty short, right? Because of course, having your serverless workloads running on the centralized environment, of course, doesn't actually reap any of the benefits that we mentioned, first off here in terms of edge, which is, of course, resiliency from outages, very, very rapid response times, and data locality. But I'm also suspecting that the question is about what is your opinion on using serverless at the edge, rather, like instead of maybe having VMs and containers as what you deploy. And I think the big issue here is rather, what is the serverless application running on? Well, in most mainstream platforms, which is usually attached to any of the hyperscaler clouds, they are running in containers. So they're actually spun up as containers that are kept alive for the duration of whatever batched or live stream that they're used for. So, I mean, in the short answer, I guess, is that it's not a or question, it's an and question. And of course, we have seen users already deploying serverless applications or applications in sort of a serverless architecture running inside of containers and using that for the lifecycle of the actual payload. And it just so happens that in that case, they also run in a VM. So there's turtles all the way down, I'm afraid. But of course, the end user or the application team experience is, of course, along the lines of the expectations with serverless. So I don't see a very strong binary approach here. I think people should deeply consider running certain components as serverless on the edge, and that's my rant. That's my rant on
That's
it.
a great wrap. Quantum greater than binary. Got it. Assignment granted.
Yeah.
Awesome.
So, so on that, we had this company in last week. It's a company out of Boulder, and I know the guy that is running it. But the company's called Fermion, Fermyon, Fermion, and it's on the concept of web assembly, right? So it's basically functions that you would create to do certain tasks. So it wouldn't be a full-blown VM that you'd have to spin up. It would be a component that you would use. I often think about pipelines for computer vision processing and plugins into those pipelines to do work. Maybe perhaps some of those pipelines could be these web assembly chunks of code. And so I haven't got very far with it, but that's probably on that same topic.
Yeah, no, that's great. All right. Next question is, what would be the first steps to deploying all these solutions that we're speaking of today? So I don't know, Mitch, you want to jump in there?
Yeah. That's a good one for me to take, and then I can probably hand it over to Carl as well. So from the scale side, it all starts with a tool that we have called Fleet Manager. And in addition to the actual infrastructure's ease of use and reliability, Fleet Manager is a huge differentiator for scale in the market, because it gives distributed edge organizations total top-down insight into every piece of infrastructure deployed for hundreds, thousands of sites. And with Fleet Manager, we have a feature called zero-touch provisioning. And as I mentioned earlier, that allows for total remote cluster deployment. So basically, you would purchase your hardware from Scale Computing, and then we have an internal connection between our internal business systems and Fleet Manager. And so when your nodes ship out from us, the hardware automatically populates in your Fleet Manager portal. And then from there, you would say, all right, I have these 3 servers that are going to become a cluster at this site. I'm going to, in Fleet Manager, remotely select those pieces of hardware and then give that cluster its configuration information. So you'll give it things like the LAN IP addresses of each node and the LAN gateway and stuff, that sort of just configuration information. And then from there, you finalize the configuration in Fleet Manager, plug all the nodes in, rack them up if they have a rack, connect them to networking, power them on, and the system will automatically initialize itself. And then the second piece is using our Ansible collection to write a playbook that can automatically deploy virtual machines on that brand new cluster. And once again, this can all be done remotely without any kind of manual intervention. Both pieces are fully automated. And using Ansible and Cloud Init, you can do things like, if you're spinning up a Linux virtual machine to serve as a host for a set of containers, you can provide it on boot with configuration information like SSH keys and users, and even run commands to do things like install third-party tools like Avassa's Edge Enforcer. And then, from there, once again, I'll probably let Carl step in and speak to what they typically see as the first steps in Avassa. Once you already have your container hosts deployed, what steps are taken in Control Tower to get those applications deployed and up and running?
Yeah, it just so happens that one of these Ansible playbooks that we've worked on together with the Scale team will actually seed the configuration into our distributed scheduling agent, such that it calls home to what we call a control tower. It authenticates itself. And the moment it's done that, you can now start deploying containers on it. So we've made it very, very friction-free, all the way, again, from hardware boot to getting the Scale software load, to installing a VM with a container runtime and our agent on it calls home, and now you can actually start deploying a containerized application. So of course, this is all available in terms of trials. So it's very, very rapid process, and I'd love to call it cheap to get started, to get those kind of first, POC style experiences that Tom mentioned before under your belt, because it's actually built to work together. Hopefully that is not a surprising conclusion here.
That's right.
Yeah. Yeah, absolutely. And I would just kind of echo that sentiment of, from a more high level perspective, as Tom and Carlo both mentioned, POCs are a really crucial first step in kind of dipping your toe in and making sure that the solution fits your specific use cases. In both Avassa and Scale, we kind of default come to the table understanding that a POC is often the first step, and we do everything we can to make sure that's as easy to facilitate and run all of the testing required to make sure that everything is in order and fits the specific requirements.
And the cool thing with the cool thing, let me just maybe wrap up with saying that, or at least this topic, is that we both stand on the shoulders of giants, right? So of course, it is your bog standard virtual machine images that runs really well on Scale. And it is your OCI compliant containers that you probably already have that runs really well on our stuff. So it usually is zero retooling or rebuilding or whatever you thought it would be in order to run your existing VM-based or container-based or serverless applications on the combined infrastructure. And actually, that's at the heart of many of our conversations. It's like, fine, you already have applications. Do you want to try what it feels like to run that in hundreds of locations? Again, not just in order of getting them up and running, but what does it look like to monitor them, to observe them, to scale them, and to lifecycle them? Again, it's usually at the heart of what we've tried to build here. So it's not a big tangled mess, but it's actually taking your existing workloads and your existing tooling and applying them to the edge.
Excellent stuff, guys. All right, another question here. What kind of businesses are these strategies best suited for? Do you think there's a business or an industry that are more well suited for strategy than others?
Well, I think the general sentiment, and we have a fantastic example of that here, is that there are a number of industries that has a lot of benefit, again, from running, or actually have a really hard time thinking of why they wouldn't run applications at the edge. And I think, of course, retail, and I'll let maybe Tom add some color to that, but we see a number of other verticals. Because, of course, when you put those glasses on, you start seeing containerized or edge applications all over the place. But you can think of another one that's pretty big and pretty far ahead is what now I understand that it's called multi-unit restaurant. Multi-unit restaurants. You can think of fast casual or fast food restaurants. There are things like hospitals, there's manufacturing, there's energy companies. And the common kind of, I guess, backbone here is that they have a lot to benefit from running certain types of compute really close to where data or humans are located. So usually when I try to pare down, the response to the question, what is edge computing? Because I get that a lot, and I don't want to bore people too much about it. My shortest answer to that is that it's when you run a lot of locations with less amount of compute in each location. And there's a lot of industries that has a need for that. So as soon as you pick up on that pattern, that industry or that vertical stands to gain benefit from that.
What do you think, Tom? Does that resonate? Is this the slam dunk for retail?
There's so many things.
Yeah.
So since we've come into we started with asset tracking, and we, over the course of 3 months, we eliminated a yearly licensing fee of over $1 million per store from a product that we were using. And so we created a platform that was very successful. Now we're moving over to shrink detection, and we are, I'll just use the term, nabbing people, every day, stealing stuff. So we're getting even more attention. And because of that attention, my meetings go from pretty much 8 o'clock in the morning till 2 o'clock in the afternoon with more groups in the organization coming to us wanting some of that action. So, and it's everything from, it's out of stock detection, it's dwell time detection, digital signage, tracking, RFID tracking, inventory management, to looking at cars in the parking lot. It's heat maps of flow of customers through the store. All these kind of things were in incubation states, but now we put together a platform that people can join in on our fun, right? And we're all component based, so we could use those kind of management tools to help us. But it's just exploding, so many places to use it. What we're working on. I think that was your question.
Yeah. No, exactly. That's exactly why we wanted that real life IRL usage case for sure. So next question, Mitch, this is a little, you were talking about POCs a little bit. Is there a demo for Fleet Manager that they can get access to?
Oh yeah, absolutely. Like I said, we facilitate POCs all the time, and by default, Fleet Manager is included in that process. And so typically what we'll do is provide the customer with a cluster or a few clusters, and then make sure that hardware is automatically integrated with a test Fleet Manager organization that we set up with them, so that they can go through the whole process Carl and I just described of provisioning the cluster with zero-touch provisioning, get workloads running, and then start testing the actual applications that would be deployed at the remote sites. And so I would just say, we're happy to facilitate that, and just contact Scale Computing by reaching out via the website or through a local channel partner, because we have a really healthy channel in throughout the whole world. So that's really easy to facilitate, and we do that very commonly.
Awesome, guys. All right, we have time for one more question before we wrap up here. And this could be any of us, any of you guys feel free. We'll use this as our last words as well. Do you have any advice for a business that is just starting to look into edge computing? I don't know who wants to take a first crack at that.
Tom has to go first on that one. Tom, would you?
Yeah, Tom, there you go. It's all you. There's your advice, Tom.
Okay, so I think I see it here. Do you have advice for a business that is just starting to look into edge computing? It would really depend on the business, right? Yeah. So, well,
like you were talking about earlier.
I'll give you an example, right? I was talking to this guy yesterday, and I was interviewing, all right, and he was playing around with computer vision, and he was playing around with these NVIDIA Jetson Nano kind of small devices, right? And he did a contract for this doctor, and this doctor was he had his clients or patients take a video of their gait as they walked, right? And so his algorithm that he ran on the Nano in the office would actually interrogate that gait and then choose the type of shoe or brace or treatment that person was most likely to get their best payback from, right? And so I suggested, coming from Boulder, and all of my whole family, we used to run. We used to go to this sports shop, and we would get on the treadmill, and the woman would watch us run, and then pronate, she would choose the best sneakers for us. And I thought, oh man, that'd be just great. Just take that over there. This small shop can use this thing and decide sneakers. So it could be at that level, right? That's where your focus is, right? At that level. But then, what we're doing is we have, hundreds and hundreds of transactions per day that we got to look at in 20 milliseconds, to make a response about whether somebody's stealing something. So it really depends on the application to give you advice around that. My journey was take what I already know. I know a lot about telemetry. Let's say telemetry, Zigbee, Z-Wave, those Bluetooth low energy. I know a lot about those protocols and how they come in, and then how we used to send those up to the cloud pretty much to get some sense out of those. So my first foray was, well, wouldn't it be better to bring it down into the gateway or into the building and see whether and what we could do with the data so we didn't send so much data up? And that's where I started, and they were simple decisions. Like, if that temperature never changes, why do we need to keep sending it up, right? We should only send it up when it changes. And so that alone is bringing intelligence from the cloud to the edge. And, you start there and then you can build off of it, right? And then you build little algorithms and, we went on to detect trying to sense in a room that it was drawing too much heat. Therefore, maybe we can conclude that they left the freezer door open or the windows open or something like that, so we could actually create an alert and send somebody. But you could do that all within the edge as opposed. And so, So I don't know what your business use case is, and it would be depending on that, how I would advise you to go.
So you're saying take what you know, then take what you have, present it to your partners. Practice. We're talking about practice, and then see how it's going to fit into your environment. I think that's the TLDR. So, but we're right at the top of the hour, so we do appreciate Carl, Tom, Mitch. Thank you so much. This is a topic that we can continue to talk about, and we will continue to talk about it because we want the conversation to keep going. We got a fully populated widget. Love seeing a full populated widget. So check out the videos in there about the Avassa platform, the mega powers of Scale and Avassa together, who is Scale Computing, and some topics, and a couple of PDFs in there as well. So definitely check that out. I want to congratulate Jambra. He's the winner of the monitor. Add that to your fleet of monitors. We appreciate it. So again, thank you to Scale. Thank you to Avassa. Thank you, Tom. And thank you to Spiceworks for making this happen. Keep the conversation going. But that's all we have for today. So don't forget to tech yourself before you wreck yourself. We'll see you next time.